Well, we got it about as close as we can get it. I have the resolution set so each mark is 50 millionths right now. And I'll concentrate on spinning that down and you can watch the needle. Okay, I got the block set up here. I touched off. I'm using a Radiac 46 grit. It's a porous wheel. It's aluminum oxide ceramic mix. And I'm going to use that for the roughing. Sometimes when you use aluminum oxide ceramic mix, it cuts really nice. But sometimes the finish isn't quite where we want to go. I have some wheels on order. They haven't come yet from Radiac. They're the wheels that I prefer to clean this up with. I got some over here, but they're down to about a little under 7 inches right now. So I'll do all the roughing on that, and if the wheels aren't in by the time I get to the finished part, and then I'll swap wheels out there because those wheels will give me a super finish. Now this block, we heat treated it. It's DC 53. I'll put a PDF in the description area where you can look at. It's an online link to a PDF where you can look and see the properties of DC 53. It's really awesome steel. It's about the same price, at least where I get it, Elroy steel. It's almost identical to the price that I'm paying for A2. A2, the base that I use on my spin fixture that you will see in some of our videos, it was $2 difference if I want A2 than DC 53. So obviously I want DC 53. Now the heat treat process on here, we went a step further. We used cryogenics or deep freezing, and what that does, it improves every aspect of the steel. Its toughness, the stress, the holding sizes, and it makes it a lot more wear resistant than if you didn't do it. Plus, they also said in the literature that it actually will grind up nicer and easier. And I'll also put a PDF in the description on the cryogenic process. But basically, if I understood things right, and don't quote me, I'm going by memory, they would heat treat the block, they'd do their first drawback, and then they would take this and then they would freeze it with nitrogen, I believe, at a minus 190 degrees, and they'd hold it there for like 30 hours. And then I think they might do another draw after that. Anyways, when you do the cryogenics, it really improves every aspect of this steel, and it's pretty awesome to begin with. You can see that I put my coolant guards up. In this case, I'll be getting quite a mess, and a lot of coolant will go off the back if I don't use it. I added the one on the front, and we'll see if we can contain the coolant. And what you didn't see on this video is I changed my coolant and the filter sock that this runs in. And just about every time I change my coolant, I will come back and I'll retouch my magnet. And it was over a year ago that I last changed this coolant. I might have just touched up the magnet one time, if I remember right on there. But if you look at my Instagram page, when I had to clean this up, really the grind pattern and the wear pattern was right in the middle. And it was untypical of what I normally get. But let me grab some stones over here, and these are precision bent stones. And if you've seen Robin Renzeni, you saw his video on that, plus looking at a lot of my videos, you'll love these stones. And I keep saying they're worth their weight in gold, and I believe that the almost perfect wear pattern I had, I attribute it to using these stones, which does not remove any material, but it would just take off them little nicks and high spots. And so I could have got by. That magnet was plenty good to grind in. It's even better now. But just check out my Instagram page and see how close this was after almost a year's use. And the coolant, it wasn't stinking, it wasn't rancid. I used distilled water with it. I got a little fish tank aerator to keep it bubbling. And the color was changing a lot, and I knew when the color's getting darker like that, it's about time to change. And so I was really surprised. I've never ground with coolant that long before getting so sour that it would just, the smell would run you right out of the building this size. I'm using a Simper oil, 1070, using a 20 to 1 mixture. Right now we're just touched on there, so we're just going to do a clean up, just kind of establish where we're at. We got a little bit of distortion in heat treat, not that much. I was actually surprised how close it came. Because I'm roughing it right now, I'm using a very fast wide traverse, and being kind of aggressive. In fact, those aluminum, ceramic aluminum oxide wheels, they actually like to be aggressive. I'm going to go ahead and take about probably 1.5 thou cut on this next cut, which I'm sure, actually I think I'll go 1 thou. I'm sure it's going to clean up on there. What I've done, I got the magnet. I don't have a full magnet. Even though this part is really thick and I doubt I'm going to get any distortion, when I want to get a surface flat, I get the magnet in where I'm holding the part where I'm comfortable with, but I still keep it at a lower setting. The only time I start using the full magnet is when I know I got a perfect flat surface that will go down to the magnet. So we'll take 1/1000 off. Should have 100% cleanup. And I got enough magnet on it so that I'm confident it's going to hold real well. You can see from spark off to here where we took the thousandths, we have 100% cleanup right now, so it was pretty darn good to begin with. You can see that I have sparks. If you can hear the wheel contacting the part or see sparks, it means it's taking material off. And one of the keys to get something really flat is you do blank passes or spark offs. You don't want to hear that wheel making any noise. You don't want to see any sparks. And when I got this magnet as flat as it is, I took 3 blank passes on there. So what we're going to do now, we're going to just take 2/10 as a semi-finish. You can see the sparks are a lot lighter. And you can see that I actually was probably about 1/8 inch into the wheel before I actually started touching, because that's what's wearing off on the front and breaking away. That's not a bad thing, that's a good thing, because the cutting edge, if it wouldn't break away, it would start dulling the cutting edges or loading up, and I would have trouble with heat in the part. You can see I'm slowing my traverse down, giving it more time to cut. Pay attention to the noise it's making. Pay attention to the sparks. Anytime you're grinding, those are key indicators of what's happening with that wheel. If I was taking a light cut right now and that wheel is singing, it's not going to leave a good finish. It's not going to be flat. It's generating heat. That's actually got a good sound to it right here. The finish actually looks pretty nice. So I'm going to do a blank pass backwards. Again, I'm slowing down a little bit on my wide traverse. You can see that it's still sparking a little bit and nowhere near as heavy. And you can hear it on its contact on the part. And right now what I'm going to do for my finish on this side before I flip it, I'm going to try to go for about a 50 millionths cut, a 50 millionths to a tenth. So you can see we're not hardly taking that much at all. You can hear it a little bit. You're really not seeing sparks. I'm slowing my traverse down even more. Traversing the Y, I'm keeping the X going pretty good. One of the mistakes that a lot of people will do in the X, they will go too slow on their traverse, and that actually generates heat in the part. So you want to come across it pretty good in the X. And our step over in the Y, I'm going a continuous speed, but I'm going slower than what I had previously. And I can't really see sparks, but I can hear it. This is really the key to getting things flat and parallel and at a high precision level. And if you don't have patience, this just definitely is not the job for you, because there's no fast way to speed this up that I'm aware of. Now we're all the way off. We're going to do a blank pass back, and then one more blank pass, and then we'll get this all cleaned out, and then we'll flip it and do the other side, and then we'll check and see how accurate it is. And we'll just take a thousandths right from the go. See, the sparks on the thousandths material is pretty heavy. And a lot of people mistakenly think that they can grind something extremely flat with those kind of sparks. So when those kind of sparks are coming off, you're generating a lot of heat. And it doesn't matter if you got flood coolant on that contact point of the wheel and the steel, there's heat being generated, and it's going to be extremely hard to get anything super flat. If you want it really flat, you gotta sneak up on it. Yeah. This right here is a roughing cut. If I get 100% cleanup, I'll go ahead and take my blank pass back, and then we'll do like on the other side. We'll take 2/10, and then we'll come down and try to take 50 millionths, and then we'll check and see what it looks like. You can see it's nice and even, and I can hear that it's making more noise at this point, so it tells me that the wheel is either dulling or loading up. So I'm going to hit the back side of this wheel. It should have fresh cutting edges to finish this out. If I kept coming across, the heat generated in there would distort this end a little more than what I want. If you use your ears, you can tell a lot what's going on in the work. You can tell the condition of your wheel. Use your eyes. I could just barely see some burn marks wanting to start. So I knew what was happening with that cutting edge of the wheel there. What I'll do is I'll redress the wheel, and then I'll come back with a nice fresh wheel on there, or a nice fresh dress, and we'll do the finishing. or I should say semi-finishing. I'm going to set my digital at 0 right there. Turn my magnet on residual. What that does is keep the magnetism in the block, and the magnet keeps the part from releasing from the magnet. I can place this on because there's no magnetism, and then I can turn it on and come over and dress this wheel. What we do is clean all the grinding grit that went on the part, so I don't have grit hitting grit. The grinding wheel hitting its own grit. And if I come back to 0, I can probably wind down, let's say 10 thousandths. And we'll just try to ease it in a little bit. There we go. Now we'll just take it easy as we're touching off now. Yeah, I don't know if Kathy can get it or not. You can see some little burn marks right in here where we started having trouble with the wheel. I can tell just by looking at it. Right here is where it was causing trouble. And I knew it was doing that just by hearing it. Can you see the little brown marks there?
A little bit.
Okay. Yeah, I don't know if that showed up on camera or not, but you have to trust me, it's there. So we just touched. We're probably 1 or 2 tenths by the time it settles. So it's not even that. It sparks to begin with. So I'm going to come across real fast just to see where I'm at. I'll come down 2 tenths from here. There's your spark for 2 tenths, and you can see quite a bit of difference between that and when we took 1,000. Okay, we'll try to come down about 50 millionths. And this would be a finish pass for this wheel. So, and we'll take a blank cut on it. And again, I'll be finishing it up with a different wheel where I'm just going to barely kiss the surfaces to get that real nice finish on there. Taking a blank pass and varying your traverse speeds on there, you get a better step over across the part. It really helps in getting things really super flat. If my crossover would work out where it's exactly the same, I would just be grinding in the same path. By varying it up, actually we'll cut in different areas on the block. I can still hear the wheel cutting. We'll do a blank pass after this. We'll get the block cleaned up and we'll check and see how good it come out. Other nice thing about the blank passes is if this wheel settles on you, it should have all the settling. A lot of times it'll drop down just less than a tenth, less than 50 millionths. And so if you're coming across and you take one pass, that transition may take place, you know, halfway in the block or a fourth away in the block. And so it's going to be actually taking a little more off one section than the other, and so your block won't be, it might be flat within a tenth or two, but it won't be that 50 millionths or less that we're shooting for. So by taking blank passes, it allows that wheel to settle in real good, because all of them will do it that I've ever worked on. When you have a digital that I have over here in this resolution, this 50 millionths, you can actually see it settle. It is time consuming to get things this flat. Well, we got it about as close as we can get it. I have the resolution set so each mark is 50 millionths right now. And I'll concentrate on spinning that down, and you can watch the needle. Oops, hitting the holes there. We'll come down in a little bit deeper. As you can see, it's easy within 50 millionths. We'll turn the scale up to 5, and here you get you can see each mark now. Each of the little marks right there is 5 millionths, so you get 25 millionths, 25 millionths. To these next marks from here to here is 1/10. It's very sensitive. Yeah, it's a lot harder to actually measure with that resolution there, but you can see it's pretty darn good. Switch back to the 50 millionths resolution. You can see it's a you see that little bit of movement in there, and then the 5 millionths resolution is what you were seeing, but we're well within the 50 millionths, and so we'll call that good. And in our next video we'll start grinding the ends.